In this video, I would like to talk about the Gaussian distribution and the 68, 95, 99.7 rule. The reason engineers and mathematicians alike love the Gaussian distribution so much is that it only requires two parameters. Awesome! Now, the first parameter is the average, or mu, and the second parameter is called sigma, or standard deviation, and we can also think of it as sigma squared, which is the variance. With these two parameters, we can know everything there is to know about the Gaussian distribution. What is the probability of getting a certain value? What is the probability of getting values between A and B? In other words, we can calculate everything using only two parameters, mu and sigma. If you remember, in the histogram distribution, every bin in the domain has a different value. Therefore, the histogram distribution can look as follows, meaning it can have a peak at point x equals 5 and another peak at point x equals 8. In other words, with the histogram distribution, I can hold two or more guesses that are both equally good. I cannot do it with the Gaussian distribution. Why? Since a Gaussian PDF, or probability density function, has only one best guess, which is the mean. It has only one peak. The mathematical representation of the Gaussian, or the Gaussian distribution, is what we call the Gaussian PDF, probability density function. And you can see the probability density function just behind me. Now, I'm sure you're familiar with this equation, but still, let me emphasize a few points. First, it is a PDF exactly like all other PDFs. What does it mean? In our case, the integral from minus infinity to plus infinity equals 1. This is why we have the normalizing factor here, 1 divided by square root of 2 pi sigma square. Thus, the integral of the PDF from minus infinity to plus infinity equals 1. This factor normalizes the entire equation to be equal 1. Another thing that we can say about this distribution is that it is symmetrical around x equals mu. The chances of being above the average are exactly equal to the chances of being below the average. And the function gets its maximum at x equals mu, where the exponent equals 1. Since we know how to calculate this whole thing, we can also calculate what is the probability of being between plus or minus 1 standard deviation. And here we arrive at the 68, 95, 99.7 rule. When we have a Gaussian distribution, the integral of the PDF between mu minus sigma and mu plus sigma gives us 0.68. Simply put, 68% of the values of the population will be between plus or minus 1 standard deviation from the mean. Let's give a concrete example. Assume that the average IQ is 100 points and the standard deviation is 15 points. What does it mean? That 68% of the people are between 85 IQ points and 115 IQ points. However, when you go to plus minus 2 sigma, we will already have 95% of the population. And when you move to plus minus 3 sigmas, we will have 99.7% of the subjects. What does it mean? That your chances of randomly choosing someone with an IQ of 145 and above are basically 0.15%. Now, I'm sure that my explanation was sufficient, but just to make sure that we are on the same page, there are a few exercises here below this video that will help your understanding of the Gaussian PDF. Good luck!